Okay, in this video, we are solving a question which came in 2021 paper 2 GCE. Question 4a. In a group of 60 football fans, 37 support team A, 28 support team B, and 29 support team C. 2 support team A and 2 support and 2 I repeat 2 support team A and team C only. 5 support team B and team C only. 7 support team A and team B only. 18 support team A only. And 10 support over 3 teams. 1. Illustrate this information in a Venn diagram. So a Venn diagram will contain 3 sets because of team A, B, and C. So drawing our Venn diagram to be made up of 3 sets. 2 and the third one 3. So that will be our Venn diagram, like that. So in our Venn diagram we have team A, team B, and team C, like that. So this has to be our universal set. So it says, so whenever you are writing a Venn diagram, make sure you start on the intersection of both the three. So make sure you start from there, which is the intersection of all the three. And the intersection of all the three, it says 10 support all the three teams. So here we write a 10 because that's where we have to start from always. And then it says to support team A and team C only. So team A and team C, we have set A and C only. It is meeting here. That's the intersection for team A and C only. So that's for 2. So 2 we are writing where I have just shaded. So we are writing a 2 where it is because it says only. 5 support team B and team C only. So for team B, we have a set of B here and a set of C there. So where C and B is intersecting, it is this part. That's where B and C are intersecting. And then there, they said we have a 5. So where I've shaded, we're writing a 5 because it is only. So I write a 5 here the way it was given. 7 support team A and team C. 7 support team A and team B. I have a and a B there. So where these two are meeting, that's why there is team A and B only. So they are meeting here. That's the intersection for A and B. So there I'm writing a 7. So here we have a 7, like that. And then it says 18 support team A only. So where there is team A only, it is this part for A only. Because if you see these two, we have a set of C which is passing in that part, and we have a 7, a set of B which is passing also at 7. So for team A only is that part which I have shaded. And then they said that there we have 18 only. So I write 18 there. And for sure, if you are to add 18 plus 7 plus 10 plus 2, we are getting this. So let's add, we add 18 plus 7 plus 10 plus 2. We are getting a 37. It was being given in the question to be 37 support team A. So I mean for that set, what I've written is correct. And then you go to B. It says team 28 support team B. So for the total team B, so this total of team B have a 28. But from this 28, to get this remaining part here, to get that remaining part, what we do, we will add a 7 plus a 10 plus a 5. So we're going to add these values which are passing in set B. We add those values, we subtract from the total of 28. So we add 7 plus 10, we're getting a 17, plus a 5, we are getting a 22. So 22 minus 28. 22 minus 28, we are getting a 6. So here in B we have a 6, like that. So in B we have a 6. We go to C. So it says 29 support team C. So for this total of C, we have a 29. Total of C we have 29. So we are adding, we add these values which passes in C. So these values here are in set C. So we add those three. We're adding a 10, adding a 10 plus a 2 plus a 5. We are getting a 17. So that's 17. We subtract from a total number of 29, which is for C. So 17 minus 29, we are getting a 12. So in set C, we have 12, like that. So after you're done filling, what you do is you add the all total values to see if you are getting a 60 which you are given. If you don't get a 60, let's say we get a 59, so you subtract 60 minus 59, that answer we write it outside here. That's why I have to write it. So you add 18 plus 7 plus 10 plus 2 plus 6 plus 5 plus 12. So we're getting a 60. So I mean that's it for our Venn diagram. So there's nothing to write in our universal set because we are getting a 60 which we were given. So it will just be like that. So for part 1 we are done. Let's go to part 2. So part 2a, it says find the number of B complement. So for B complement, that means that whatever in B, we exclude them. Now what is remaining is what we want. So for B, if I was to write a B, so that B I have a 7, 6. So let me write it well. So for B I have a 5, I have a 6, a 7, and a 10. So that's my set B. Now for B complement is equal to, so B complement meaning I'm excluding these numbers which are in B from our set. So now what is remaining will be our B complement. So excluding those numbers, I'm remaining with 18. Let me write it well. I'm remaining with a 2, a 12, and a 18. So that's my B complement because I have excluded those values which are in B. So now what remaining is our B complement. But our question says we find the number. It says a number of B complement. So number of B complement, you simply add those which are in B complement. You get a number. So I add in a 2 plus 12 plus 18. Our answer. So when you add the 2 plus 12, you get a 14. 14 plus a 8, we are getting a 32. So our answer here is 32. So that's our number of B complement. So part A, we are done. We go to part B. So part B. So part B says finding the number of A intersection B complement. So first thing, let's start with what is in the brackets. We start with finding the A intersection B because that's what is in the brackets. So A intersection B. Look for what is common, what is found in A and B. So what is found in A and B, we have this part. So that's what is common in A and B, which is a 7. So here we have a 7. So 7 is our A intersection B. So now finding A intersection B complement. So this simply means that from our total set here, we exclude a 7 because a complement meaning we're excluding a number which is in A intersection B. So excluding a 7, we remain with a 2, comma, 5, comma, 6, comma, 10, comma, 12, comma, 18. So that's our A intersection B complement. But our question says we find the number, looking for the number of A intersection B complement. So since we're looking for a number, so just simply add. So add those values which are in A intersection B complement. So I add in a 2, add in a 2 plus 5 plus 6 plus 10 plus 12 plus 18. So that will be our number of A intersection B complement. When you add 2 plus 5 plus 6 plus 10 plus 12 plus 18, we are getting a 43. So 43 is our answer for number of A intersection B complement. So part B, we are done. We go to part C. Solving part C. So we are solving for C. C, we wanted to find the number of A union B. So number of A union B complement. The first thing, let's find what is in the bracket. We find A union B. So finding A union B. Union means you are combining. You combine what is in A and B. So combining set A and B. We are combining these two sets, set A and B. We combine those sets. So combining A and B, we are getting a 2, 5, 6, 7, 10 and 18. So that's our A union B. So now finding A union B complement. So having a complement, that means that whatever is in A union B, we exclude them or we omit them. So we are removing 2, 5, 6, 7, 10, 18. So now we write what is remaining. From our set, omitting those values, remain with a 12 just like that. So now finding the number, we wanted to find the number of A union B complement is simply a 12 because there is no other number to add. So just a 12. So that's it for this video. That's it for this question. We go go now to 4b. So going to 4b, a 4b came under the matrices. So 4b says, given that the determinant of the matrix A is equal to 2x minus 1, 1, 4, negative 2 is negative 10. Find the inverse of x. 2. Number 1, find the value of x. 2, the inverse of matrix A. So solving that question, I have been given a matrix to B. So this is our part 1. Our matrix A is equal to 2x minus a 1. You have a 4, 1, negative 2. So that's our matrix. So looking at this matrix, we have two diagonals. We have a diagonal which we call the major diagonal, the one in the right side. We call it a right. We call it a major diagonal. In the other one, this one we call it a minor diagonal. So in finding the value of x, we equate the product of the major diagonal and the minor diagonal is equal to the determinant. So you say this one is equal to, we are equating to negative 10, which is our determinant. So that means that we are multiplying. We multiply a negative 2 times 2x minus a 1. Here you say minus 1 times 4, like that, is equal to negative 10. So I have just multiplied those which are in major diagonal minus I multiply those which are in minor diagonal. So this one was our major diagonal. This one was our minor diagonal. So I just multiplied the major, and then here it is always a minus. We don't use any other sign. Always use a minus. So we multiply negative 2 times negative 2x, it is a negative 4x. Negative 2 times negative 1, it is a negative 2, minus 1 times 4, it is a 4, is equal to negative 10. Negative 2 minus 4, sorry, it's supposed to be a positive because we multiply the negative 2 times the negative 1, supposed to be a positive 2. So we have a negative 4x. So 4 minus, 2 minus a 4, I'm getting a negative 2 is equal to negative 10. Negative 4x, collecting the like terms, negative 2, you go where there is 9, and then after crossing the equal sign, it will be positive 2. So it will be negative 10 plus 2. So I have a negative 4x is equal to negative 10 plus 2. I'm getting negative 8. We have a negative 4x, but our interest is to remain with a x. So to eliminate a negative 4, we divide both sides by negative 4, this side by negative 4. So negative 4 and negative 4 will cancel. So our value of x is equal to negative 8 divided by negative 8. I'm getting a positive 2, because negative divided by negative, the answer is positive. So our value of x is 2. So that's for question 1. We go to question 2. So question 2, we want to find the inverse of A. So finding the inverse of A, we have our matrix A here to be 2x minus a 1, 1, 4, and a negative 2, like that. But our value of x we found to be a 2. So wherever is x, we are substituting a 2. So it will be 2 open bracket 2 minus a 1, 1, 4, negative 2, like that. So therefore matrix A is equal to 2 times 2, 4, minus a 1, getting a 3. So I write a 3, 4, 1, negative 2. So that's our matrix. So now like finding the inverse. So we say A inverse so let me write our A is equal to 3, 1, 4, negative 2. So A inverse, we are saying A inverse, so A inverse is equal to, you say 1 over determinant. So our determinant, it is 1 over determinant. So let me just give you a general formula which we use. Let's say we add the let's say we add matrix Q. Let's say we add matrix Q. Let's say we add matrix Q is equal to A, B, C, D. And this matrix Q tend to have a determinant of, it has a determinant of 2. So finding the Q inverse is equal to 1 over determinant open bracket. So we have a major diagonal, our major diagonal to be this one, and we also have a minor diagonal and a minor diagonal. So in major diagonal they change position. So this one will change position, but in minor they change signs. So minor diagonal they will be exchanging signs, but in major diagonal they will be exchanging position. So finding a Q inverse, it will be, so D will go over is A. So a D will come this side, and then a will go over was a D. That's in our major diagonal. Minor diagonal will change signs. Since they are all negative, since they are all positives, they will become negatives, like that. So that's our general formula which we use. So I repeat, in major diagonal, when finding the inverse, they change position. In minor diagonal, they change sign. If it was a positive, if they were all positive, they will become negative. If one was a positive, the other was a negative, they will exchange signs. So now going back to our question, we have a major diagonal here. That is our major diagonal. We also have a minor diagonal. That's our minor diagonal. So in major diagonal, they will change position. Minor diagonal, they will change signs. So they will exchange signs. So finding our A inverse. So we will say A inverse. So that's a symbol for inverse is equal to 1 over determinant we are given to be a negative 10. So it will be 1 over negative 10 open bracket. Major diagonal we are exchanging position. So 3 will go over is negative 3, like that. So here we are going to have a negative 2, and then a 3 will go where there was a negative 2. So a 3 will go that side. And in major diagonal, I mean minor diagonal, they exchange signs. Since they're all positive, they will be negatives. So negative 4, negative 1, like that. So that's it for this video.